Hi guys, I'm really sorry. I had some urgent work, so we will start in a bit. Hopefully, you guys have solved problems based on Koenig section. If you have any doubts, please let me know. Okay, so we'll close Koenig section today. And if you don't have any doubt, that means if you haven't solved problems, what we are going to do, we are going to just revise it. Okay, so that all the Koenig section, like from circle to hyperbola. Okay, hopefully we can do it in next 40 minutes. And okay, so just give me a few minutes. We'll start. I don't have the host access. Let me get it. Thank you. Okay, so did you guys try solving problems from Koenig section? You have any doubt?
Yes, sir. And miscellaneous example.
Sorry,
In miscellaneous examples, sir.
miscellaneous examples. Okay,
Yes, sir.
so okay, miscellaneous example of circle.
Not circle, sir. The
So
18th. Yes, sir. The 18th
just
and
a minute.
19th chapter.
Okay, wait. Let me open NCRT book. Oh. Yeah, tell me which question.
So page number 262, 18 and 19, sir.
260?
262.
260 again, tell me please.
262, sir. After exercise 11.4.
It's example 17.
18 and 19, sir.
Okay, example 18 and 19. Where is 18? Okay, 18. A beam is supported at its end by support which are 12 meters apart since the load is concentrated at its center. There is a deflection of 3 centimeters in the center and deflection of the shape of a parabola. Okay, so it's given whatever deflection it is. Okay, I think you can see. Sorry. Whatever deflection you see here. Okay, so the deflection is given in the shape of parabola, right? Where do you have problem in this? Tell me so I can start. Did you understood the problem?
No, sir, I can't understand the questions.
Okay. See, it's given. I'll try to explain it in terms of parabola only. Okay, so you are given a parabola. Okay. All right. So this parabola you are given. Now, let's draw the axis of parabola. So this is one of the axis, and see it's written now that deflection is in shape of parabola. It's written, right? Yes or no?
Yeah, yes, sir. Yes, sir.
And see, one more thing is given that since the load is concentrated at the center, there is a deflection of 3 centimeters. That means at the center, let's understand in terms of load. See, this is mechanics problem. Okay. In physics, you'll be solving physics, let's say physics, mechanics, you'll be solving problems like this. So it's whenever there is, suppose this is a rod or something, any beam, like in your home, we have beam, right? And because of your roof, what happens? There is a uniform distribution of load on this beam. Okay. So because of this load, there will be some deflection on the beam, so that the beam deflects so that it should not damage the structure. Okay. So kind of in civil engineering, you'll be studying mostly like this. So the deflection is in shape of parabola. That's what it is given. So this is the beam. And of course, it won't deflect this much. It will deflect a little bit. And that is in shape of parabola. Okay. So the maximum deflection occurs where? At the center. Okay, that's what it is given. At the center, maximum deflection is happening. So let's say this will be the axis. So axis passes through the center, right? Yes or no?
Yes, sir.
Okay, so axis will pass through the center. Now this is the beam, the deflection of beam. So which distance is given? So let's say, now this was the initial position of the beam before there was any load. So this deflection is given 3 centimeter. Maximum deflection is 3 centimeter. Okay. Understood? So this is the information given in the problem. So this is, let's say, your y-axis, and you can draw anywhere x-axis wherever you want. So we have studied about this type of parabola. So let's say this is the axis of parabola. Okay, now let's say this is the center vertex. This will be the vertex of parabola A, 0, 0, isn't it? We have studied only this type of parabola. Yes or no?
Yes, sir.
Yeah. So this is the information given to you. That means this is your focus. Focus is where? At. So first tell me what will be the equation of this parabola? General equation of this parabola. If this is y and this is x-axis, what will be the equation of this parabola? If you don't know the value of A, focus, or anything else. So what is the general equation of parabola of this shape? Tell me.
Sir, x square is equal to 4ay.
x square is equal to 4ay, is it? Or y square is equal to 4ax?
X square, sir.
Why x square, man?
Sir, it's laying on,
Tell me. Yes, yes. Go on, tell me.
it's laying on the X axis, sir.
Yeah, it is. It is. See, it is concave upward. Okay.
Yes,
So
sir.
this parabola is y square is equal to 4ay, sorry. X square is equal to 4ay. This is the general equation of this parabola. We have studied that, isn't it? Haven't we? Okay, let's see where we have studied. Okay, so this is the parabola. This parabola, right? This is the parabola we are talking about. Yes. Okay, so which shape? Let's say this one. The shape of parabola. Either it is upward or downward. What will be the general equation of parabola? X square is equal to 4ay. Negative, that means it is concavity is downward. If concavity is upward, that means that will be positive. Okay. So that is the general equation of parabola. Do you have doubt here? In the general equation of
No,
parabola?
sir.
Fine. Now, see, you need to find the focus point, isn't it? First, you have to find focus where the focus lies, isn't it? Yes or no?
Yes.
Okay. Now, how you will find the focus? See, it's given that the beam is 12 meter apart. Okay. So from here to here, this length is given 12 meter. Right? If this length is 12 meter, that means if you are taking A as origin, okay, what will be this point? This point? What will be this point? It is in the middle, right? So that means this point, coordinate of this point will be something positive 6 comma some y, which we don't know as of now. Let's write y1, and here it will be negative 6 comma some y1, right? So if, isn't it? Yes or no?
Yes, sir.
Yes, why yes?
Sir, because it's 12 meters apart, sir. So from the middle, it's 6 meter each side. 6
Are you
centimeters.
sure? Okay. Now it is given, it is this point is 3 meter upward. Sorry, 3 centimeter, this point, right? Because if you are drawing this parabola and if this is the origin, the maximum deflection is how much? 3 centimeter, right?
Yes, sir.
So what will be the coordinate of this point?
Uh, uh, Sir,
Yes, sir. Please tell me.
so once again, sir, I'm confused.
See, it is on y-axis, no? It is on y-axis. So
Yes,
x coordinate will be 0. So if x coordinate will be 0 and y coordinate will be how much? Y1, right? And y1 is how much? 3 centimeter.
Yes, sir, but the units differ, sir. So how can we write it as 0 comma 2? Okay.
3 by 100 meter. No, y1. You just write y1, some value y1.
Okay.
Now imagine, now this parabola is passing through which point? This is passing through, let's say, point A, point B, and point C, right? What is the coordinate of point A? 6 comma 3 by 100. What is the coordinate of point B? See, it is not passing through B. 0 comma 3 upon 100. What is the coordinate of point C? Minus 6 comma 3 upon 100. So the parabola is passing through these 2 points, A and C. And what is the equation of parabola? X square is equal to 4ay, right?
Yes.
Now, you can plug these two values in this parabola. Okay, so let's plug A. Let's plug A 6 comma 3 by 100 into this equation. X square is equal to 4ay. So what is the value of x? 6. So 36, isn't it? 6 square is equal to 4 into a into y. Y is how much? 3 upon 100. Yes or no? Because you have to match the unit. That's why it is 3 upon 100. Okay, because we are writing in meter. See, this is in meter. So you must write this unit also in meter. Okay.
Yes.
So this is 36 is equal to 36 upon 4 into 100 upon 3 is equal to a. Is that correct?
Yes.
Okay, so this will be 25. This will be how much? 12, isn't
Yes.
it? So a is equal to how much?
300
300. What is the unit of a?
meters.
Are you sure?
Yes, sir.
Yeah, because see, unit of x is meter, right? So that means
Yes,
it is
sir.
meter square. And this side 4 is a constant. A,
Yes.
we don't know the unit, and y unit is meter. So meter
Meters.
will get cancelled. So a must have the unit of meter. Okay.
Yes.
So a will be equal to 300 meter. Understood?
Yes, sir.
Okay. Now, okay, so you have got the parabola. What parabola you have got? So now this red curve is the equation of parabola. X square is equal to 4ay, right? Now value of a is known. So x square is equal to 4 times of 300 is how much? 1200?
Yes, sir.
1200y. So this is the parabola. Okay, now what do you need to find out? So this is the equation of parabola we have got. Okay, now what do you need to find out? You need to find out, let's read the problem. So how far from the center is the deflection? 1 centimeter. Okay. Now you need to find out from center, from this point, or the center of parabola is, let's say, this point. How far from this point in x direction? Of course, x direction, the deflection in y direction is 1 centimeter. It will be here and it will be here. 2 points. Okay, one here, one here. Understood?
Yes, sir.
See, if the beam is bending like this, that means if the maximum displacement is here 3 centimeter, so somewhere it will decrease, keep on decreasing. Somewhere it will be 2 centimeter, somewhere it will be 1 centimeter. That's what they are asking. Where is the deflection? Is 1 centimeter. The deflection is 1 centimeter. So here and here there will be 2 points. Okay. Okay.
Yes, sir.
So let's now draw it again. So let's say this is the this is the parabola that you have got. Okay, and let's draw the axis. See, you can solve the problem by looking at Google or somewhere, but to understand our problem is most important thing. Okay, so always try to understand the problem rather than just solving it, rather than just substituting the value. It won't help for long. Okay, if you want to understand it for a longer period of time, or so try not to memorize. Okay, so this is the parabola that we have found. Okay. Yeah. Okay. So this parabola equation is this one. Now it is just try to understand. This is y, this is x. Okay. This length is how much? This, let's write all the coordinates. So this point is 0, 0, right? This point somewhere here, it will be how much? 6, 0. This point somewhere here, it will be minus 6, 0. This point is 0, 3 upon 100. This point is how much? Minus 6, 3 upon 100, right? This point is 6, 300, 3 upon 100. Fine. So we have got these points. Now you see the maximum deflection here is 3 centimeter. Somewhere around the deflection decreases, right? Because the beam is deflecting most on at the center. This is the center. So somewhere around here and here, the deflection will be how much? 1 centimeter. Somewhere it will be 1 centimeter. Somewhere on the beam. Okay, somewhere the deflection must be 1 centimeter. This is 1 centimeter. That means this coordinate, this point, we need to find out. This coordinate is, see, display, this should be how much? What will be the coordinate of this point? X we don't know, right? Let's write X as X1 because X1 we don't know. Comma, Y is how much? Tell me. Y is how much? Huh? See, if it is 1 centimeter from here, right? 1 centimeter from here. Maximum is how much? From here to here, what is the length?
3 centimeters.
So, and here to here, it is 1 centimeter. So from here to here, how much it is?
2 centimeters.
2 centimeters. So 2 centimeter in meter, what you will write? 2 upon
2 by
100,
100.
right? So this coordinate, this point, let's say X. Okay. So the coordinate of point X is X1, comma 2 upon 100, right? You need to find X1. Can you not find X1? You have the equation of parabola X square is equal to 1200 Y. Fine. You just substitute this value here and tell me the value of X1. Understood or not? See, because this point X is on the parabola, right? See, any point on the parabola, here, 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 all point will satisfy this parabola. Understood? Understood or not?
Yes.
Okay. Solve it, solve and tell me the value of X1. Anybody else is having problem? Yeah, anyone else is having same problem? So Murli, what's the value you got?
Sir, getting X square is equal to 24 meters.
Tell me the value of X square, buddy. X1. Tell me the value of X1, not X square.
2 root 6. Sir.
2 root?
6. Sir.
Okay. So just substitute it here. How, what you will do? So X1 square is equal to 1200 into 2 upon 100.
Yes.
This will be 24.
24.
So 1 will be equal to plus or minus square root of 24, right? So this will be equal to plus or minus how much?
2 root 6.
2 root 6. So that means there are 2 points, right? 2 points where the deflection is this much. 1 point is here and 1 point is here.
Yes.
Right? So this point is X dash, or let's say X dash. So this point is what? Minus 2 root 6 upon comma 2 upon 100, and 1 point is this, which is 2 root 6 comma 2 upon 100. Okay, both these points lie on this parabola. Understood? So it is not 1 point, there will be 2 points. So the solution here in this is solved problem, right? It is wrong solution. Matlab not complete solution. It is not wrong, but not complete.
Okay.
Okay, incomplete solution it is. All right. So these type of problems you'll face a lot when you are solving, when if you are choosing civil engineering or if you are going into engineering. So these type of problems will be there a lot. Okay. Anyway, anybody else is having doubt or problem, or shall we revise once from circle to everything, whatever equations we have learned? Nobody is having doubt. Nobody is solving problems. Dude, in order to understand, you have to solve problem. It's not me who can do it. Okay, it's totally up to you guys. So what are the types? Yesterday only we have studied hyperbola. So what are the types of hyperbola we know of? What is the definition of circle? How do you define a circle? Murli?
Sir, circle has same radius.
Sorry, circle?
Has same radius in all sides.
Okay, same radius on all sides. That's very broad. See, this line here, it represents a circle, right? That means it is equidistant. All, see, locus of a point. Let's say there is a point here, okay? And you fix its distance from a fixed point, okay? Fix it this distance, and that distance is called R. So this is fixed point, okay? So fixed point, and the and this length is fixed length, okay? Fixed point, fixed length. Whatever points this red dot will trace is called a circle. Understood? And this fixed length is called radius. Fixed point is called center. Understood? That's what circle is. Understood? Yes or no? So how you will write? A circle is the locus of a point which moves in a plane in such a way that its distance from a fixed point, okay, remains constant. Okay, that fixed point is called center. This fixed point is called center. Center of the circle. And the constant distance, where is, see, this distance is called radius. All right, so that's how we define a circle. Understood? See, there are a lot of theorems based on circles, like theorem of tangents and all. We have solved, we have had the general or standard equation of circle. So thus any circle can be defined using the equation x minus h whole square plus y minus k whole square is equal to r square, where r is the radius and h comma k is the center of circle. Understood? So we have seen different types of circle. Okay, I have given you the definition of circle as well. All right. Properties also, we have seen different properties, like there is no circle that will pass through 3 collinear points. So if 3 points are collinear, like A, B, and let's say some point C, so no circle can pass through all these 3 points. Okay, if a circle can only pass through 2 collinear points, not 3 collinear points. Understood? It is very, very important property. May not be now, but you will understand. Okay, just all right. So these are some of the properties. Now, if the circle is on x-axis, what will be its equation? Because k will become, you will have a radius will be equal to how much? K. K will become the radius. So this will be your equation of circle, this one. And if the circle is touching y-axis, so this will be the equation of circle. Okay. If the circle is touching x and y-axis, both axes, so this will be the equation of circle. Both this and this, both will be the equation of circle. Whatever you want, you can write it. So we have solved some of the problems based on circle. Do you guys have any doubt in circles? Circles, because in your textbook, very easy problems are there. If you want, we can go one by one. Do you have any doubt in circles? In exercise 11.1, is there any problem that you are facing trouble with, or in miscellaneous problems? Did you try solving exercise 11.1? Huh? Anyone? Any doubt? See, we have also seen one equation. It's whether a point will lie inside a circle or will lie outside a circle. Remember? See, the position of a point. So, position of a point with respect to a circle. See, there are 3 points: point P, Q, and R. So this is the general equation of a circle: x square plus y square. So plus 2gx plus 2fy plus a constant c, where radius will be equal to square root of g square plus f square minus c, and h is equal to minus g, k is equal to minus f. Okay, so if the value of s, if you substitute this point, plug this point P inside in this S, and you are getting the value S1 value greater than 0, that means point is outside the circle. S2 is means S is if equal to 0, that means point is on the circle, and if it is lesser than 0, that means point is inside the circle. Okay, we have solved one problem based on it. See, this is the problem we have solved, right? So this equation is given. Okay, so these are the 2 points, and this is the equation of circle given to you, isn't it? So you just substitute these points here in this circle, equation of the circle. If S is great, if you find S lesser than 0, see, we have got S lesser than 0, that means point P is inside the circle. Q value, what we have got, Q is greater than 0, that means Q is outside the circle. That means if this is the circle, point P is inside and Q is outside. This is P, this is Q. In the equation of circle, you just substitute these values. Okay, like let's say there is a question number 15 in your book. Okay, question number 15 is x square plus y square is equal to 25. Okay, and they have asked 2.5 comma 3.5, not minus 3 point. So if this point is inside this circle, just substitute the value, put x value here. If you put x, what you'll get, 2.5 square plus y, if you put 3.5 square, okay, minus 25. This is s. Okay, so what value of s you are getting? 2.5 square is how much? 6.25 plus 3.5 square is how much? Anyone? How much is 3.5 square? So it is 12.25 minus 25. So if you add 12.5, okay, so 12.25, sorry, 12.25 plus 6.25 is 18. So this value is lesser than 0. That means negative value. That means point P is inside the circle. P is inside the circle. Okay. So even if you draw this circle, you'll get it. This circle is something like that. So center is on the origin. Okay. Understood? So next was parabola. How do you define a parabola? Anyone please tell me how you will define a parabola? Okay, let me give you a very general equation of a circle. Oof. General equation of circle. Okay, so this is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is general equation of parabola, sorry, circle. And r radius is square root of g square plus f square minus c, and the center is minus g minus f. Okay, so this is general equation of circle. Understood? See, there are different equation form, like diametric form of circle. Okay. And special circles, intercept made by circle on axis, and which is not there in your syllabus. Condition of tangency is there? No, right? These things are not there in your syllabus. So pair of tangent, there is the equation for pair of tangents, which is again not there in your syllabus. Yeah, basically nothing is there in your syllabus in NCERT. So let it be. Parabola, can anyone define parabola? So parabola is also a part of conic section, right? This is also a part of conic section, isn't it? So see, suppose, let's talk about conic section. Conic section. That means we are talking about parabola, ellipse, hyperbola, and circles. Okay. Now these all have only one equation. It can be defined using one equation. That means if, especially these three, circle is much easier than these three, right? So if, let's say, the equation of directrix Lx plus My plus N is equal to 0. Okay. Okay, before we go ahead again, let's define any conic section. So how you will define any conic section? So conic section, it can be defined as the locus of a point which moves in a plane. Of course, see, all we are talking about is 2D figures. That's why we talk about only x and y axis. We do not talk about z axis. Okay, so all are in one single plane, so that its distance from a fixed point is in a constant ratio to its perpendicular distance from a fixed line. Okay, now this fixed line is called directrix. Okay, and this fixed point is called focus. Okay, so for this is valid for all conic section. That means, let's say this is the directrix. Okay, any line, the directrix, and let's say the focus is somewhere S. Sorry, somewhere we have the focus S. Now this is the fixed point, focus, fixed point. All right, in case of circle, this is center. Okay, now directrix, this is the directrix line, fixed line. This is called directrix. Now what it says, it's the locus of a point. So let's randomly suppose there is a point P. Now P will move only in a path such that if you join PS, suppose you joined PS and you draw a line perpendicular from P on this line on the directrix. So this is perpendicular. Okay, and suppose let's say it meets at point M. So the ratio of PS this and the ratio of this PS upon PM is a constant, and that constant is called eccentricity. Okay, is a constant we have written, no? So which moves in such that the distance is a constant, and this constant is called constant ratio. This constant ratio is called eccentricity. Okay, that's right. Now, if eccentricity is equal to 1, we say it is a parabola. If E is lesser than 1, it is ellipse, it will form a ellipse. And if E is greater than 1, it will be a hyperbola. Okay, so that's how we define. Now let's assume, let's say the equation of this directrix is Lx plus my plus n is equal to 0, because it's a straight line. So this is the general equation of straight line. Okay, and the fixed point P, S is, let's say P comma Q. The coordinate of this point S is P comma Q. So PM, how we can find PS from using distance formula? PS. Okay. So PS is some XY, we don't know, right? Because it is moving in space. So PS will be equal to square root of x minus p whole square plus y minus q whole square, right? And PM will be equal to modulus of Lx plus my plus n whole divided by square root of L square plus n square. Sorry, m square. We have studied that in straight line because PM is perpendicular. So this is the distance of perpendicular, right? Now we know that PS upon PM is equal to E, right? So if you multiply these two, 1, 2, it will be equal to, so take the ratio of 1 and 2, it will be equal to 3, right? So from here we can write L square plus n square into x minus p whole square plus y minus q whole square is equal to E square Lx plus my plus n whole square. Okay, which you, if you solve further, okay, this can be written in form of quadratic equation with some constants. Let's assume that. So let's say the coefficient of x square is a, so you can write ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this is called the general equation of any conic section. Now it depends upon the value of E, or just forget this because it is being too complicated. So this is the general equation of any conic section. Okay, any conic section. If you know the directrix, okay, and from directrix only you will get the value of Lm, right? The focus. So from focus you will know P and Q, and eccentricity, if it is equal to 1, then it will be a parabola. If it is lesser than 1, it will be ellipse. If it is greater than 1, it will be hyperbola. Okay. So this is called the general equation of any conic section. All right. We have studied different types of parabola. Okay, parabola, mouth opening towards the positive x-axis, mouth opening to the positive y-axis, right? Mouth opening to negative x-axis, mouth opening to negative y-axis. So these are the types of parabola we have studied. Okay. Yes or no? Ellipse. These are the two types of ellipse we have studied, whose center is always on origin. Okay, this one is this ellipse, and another one is this vertical ellipse, right? So this is called your semi-major axis, and this is semi-minor axis. In this case, B is your semi-major axis, and A is your semi-minor axis. All right. In case of hyperbola, we have studied this type of hyperbola. Okay, so here is your focus. This is called transverse axis, and this is called conjugate axis. All right. In conic section, E is equal to for ellipse is equal to 1 upon 1 minus B by A whole square. Okay, for this parabola, this for this ellipse, and here E is equal to square root of 1 upon B by A whole square. Sorry, A by B whole square. A by B whole square, because A is lesser than B. Here B is lesser than A. Okay, that's right. Now in case of hyperbola, eccentricity is equal to 1 upon 1 plus B upon A whole square. right? Isn't it? Now there is another hyperbola which is called conjugate hyperbola, like this, conjugate to this hyperbola. Okay. Then we studied symmetric hyperbola or equivalent hyperbola, in which e is equal to square root of 2. Yesterday only we had studied. So equation becomes x square minus y square is equal to some constant. Okay. Some constant it will become, because a is equal to b. So let's write c square, b square, or a square, whatever you want, you can write. Then there is third type of hyperbola, which is rectangular hyperbola, which is x into y is equal to some constant. Let's say c or c square, usually it is written, doesn't matter. Okay, so product of xy is equal to a constant. So that type of hyperbola is this one. Okay, so these are the vertices of that hyperbola, c comma c and minus c comma minus c. Okay, so these are the types of hyperbola we have studied. Hopefully you guys can just revise it once, and if you want this notes, let me know. Okay, let me know, or I'll give you my email ID. Okay, or you can WhatsApp me at, if you want this note, please WhatsApp me here. Thank you so much. Bye. Okay, I'll end the class. Okay, thank you.
Thank you, sir.
Thank you, sir.